Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today we are going to look at the connection between a unit circle and some of the trigonometric functions that we have done in some of our videos. And this of course is going to assist us appreciate the subsequent developments, which are going to be of course application areas of trigonometric functions. Now in this case I'm going to use a set of illustrations for basically the unit circle and the two dimension coordinate system, and this is going to consist of the x and y coordinates given as such. So in this case we're going to look at different parts of a unit circle, and we had mentioned that basically we can define a unit circle as a circle of a radius unity which is centered at the vertex of an angle, perhaps theta or x. So in this case I'm going to give this particular point for O as a reference point for that specific vertex, and I'm going to draw a triangle that is contained within this circle, and this is going to be a right triangle given as such. So in this particular case we said that we can be able to give this specific point an arbitrary point that is of course a point of or rather a point of connection between this extent for x and y coordinates, and of course we can be able to give these particular points as the function over the cosine and the sine of theta. Remember from description of the trigonometric ratios, we said that the sine and the cosine of theta are going to form a set of trigonometric ratios, which in a sense are going to be referred to as periodic. So this is going to be, of course, more elaborate when we are going to define the concept of that specific, those two specific ratios insofar as graphing is concerned. So if we defined this specific circle as a unity circle with a radius that is centered as the vertex, then therefore we can be able to give these specific coordinates along the x-axis as 1, 0, and then this is at -1 along the negative y-axis. We can have a coordinate of 0, -1. So this is at a +1, and this is at -1. This is a +1 along the positive y direction, negative y direction, and negative x direction and negative y directions respectively. So we can give their respective coordinates as such, and this is going to be -1, 0 given as such. So for a unity circle that is having a radius of unity, which is basically 1, then therefore we can be able to give this particular point that is of course a point that is this specific point along the what we refer to as a terminal point P. So we can be able to describe this terminal point P in terms of the cosine and the sine of an angle, which of course has been extended from this specific x coordinate along the terminal point to this point P, and then we can be able to give the length along this specific y direction in terms of course the sine, which is going to be given as the sine of x respectively. So we can be able to describe this particular extent along the x-axis as the cosine of this specific angle, and this one as the sine of that particular angle. So therefore when we are going to describe the concept of the cosine of x, this is going to form the first coordinate of the terminal point P on the unity circle for an arc length that is being subtended by this particular angle x along this circumference. So therefore this is going to form our first set of what we have referred to as a coordinate at the terminal point P. So therefore we're going to have the cosine of x, and then for the sine of x, this is going to form a second coordinate of the terminal point on the unit circle for an arc length which has been subtended over by the angle x, and therefore we can be able to describe a point P in terms of its coordinates for the cosine of x and the sine of x given as such. So therefore from this particular set of a unity circle, they're going to assist us find various values for the sine and the cosine of these specific functions along this particular circle. And I'd mentioned in one of our videos that of course this particular unit circle is going to form what we refer to as quadrants. So basically I can be able to divide this unit circle in terms of 4 quadrants, and these are going to be the first, the second, the third and fourth. Remember, we said that we are going to form angles. We can be able to define an angle as an extent along the x-axis towards by the terminal side in the anti-clockwise direction. So therefore, we're going to form an angle in the increasing direction of the anti-clockwise direction shown by this specific arrow. So therefore, we're going to number our quadrants from the anti-clockwise direction going in this specific direction as shown by the arrow, and therefore we are going to have them as the first quadrant, the second, the third, and the fourth. Now, with regard to the trigonometric functions, we're going to see that for various ratios which are going to represent specific points as the terminal point, the terminal side move along this circumference, we're going to have the functions of the sine and the cosine of theta being described using this general, the values of the cosine and the sine of theta being described using this general illustration for the terminal point at this particular point P. So as P moves along this specific circumference, then therefore it's going to describe the functions of these two specific trigonometric ratios. So therefore, if we try to look at this, we're going to have an acronym that is going to, of course, assist us try to identify various values for the trigonometric functions along this unity circle. And therefore, we are going to have it using this particular acronym given in terms of acts. So I've mentioned this one in one of our videos, and this basically refers that for the first quadrant, which I've mentioned here, we're going to have all the trigonometric ratios of the sine, the cosine, the tangent of a function, perhaps, or the tangent of x being given as a positive value. So this case, for all the values of these specific ratios, the first quadrants are going to be positive. And then for the second quadrant, we're going to see that only the sine, so this for the first quadrant. So for the second quadrant, we're going to see that only the sine function is going to be positive in this specific quadrant. So this is a stretch of angles ranging between 90 and 180 degrees along this negative or the anti-clockwise direction. Now for the third quadrant, all the tangent over this particular value are going to be positive, and of course that is going to range between the values of 180 to 270 degrees, and of course this is going to be of course for the first cycle, the first revolution of this specific angle. And then lastly, we're going to see that for the fourth quadrant, only the cosine of this specific function are going to be positive in that respective order. Now, so we mentioned from our previous discussions, we said that from a unity circle, we're going to have a full revolution that is going to consist of 2 pi radians, and this is equivalent to 360 degrees. So therefore, we can be able to allocate various values for these specific functions of the, especially the sine and the cosine of a function x, or of a value x, and these are going to give us what we refer to as periodic graphs. And these periodic graphs of functions are going to be displayed particularly for the cosine and sine of theta given as such. So in most of our discussions, we're going to illustrate this in terms of radians, and therefore they're going to be perhaps fractions of radians which can be illustrated as such. So we have said that 2 pi radians represent 360 degrees. So in this case, then therefore a pi radian is going to represent 180, and this is a pi over 2 radians is going to represent 90 degrees, and they're going to either increase or decrease in that specific ratio, as we're going to see later. So in this case, as we go ahead and perhaps try to analyze the functions of trigonometric ratios, especially for the two ratios of the sine and the cosine, I'm going to use these particular ratios for the sine and the cosine of theta respectively. So of essence for us to remember is that the implication of a unity circle is going to give us the specific coordinates for the first coordinate at the terminal point along this circumference of a unity circle, which is subtended by this arc length x, and of course or the arc length with this angle x, and these are going to give us the values for the cosine and sine of theta in that specific order. And secondly, we have seen that of course we can be able to have this acronym that is going to assist us identify which values for the positive and negative values are going to be illustrated in various quadrants, especially for the first or the full revolution of this specific circle. And lastly, we're going to see that, as I've mentioned, this ratio, the radius is going to form a unity. So in this case, if we had a right triangle that has been subtended in this particular case for the cosine of x and the sine of x, we can be able to use Pythagoras theorem in order to describe this particular subtended angles for x. And of course, we are going to describe this in terms of these various parts of the triangle which has been subtended at this particular point, terminal point, or from this particular vertex also. Therefore, we can be able to describe this in terms of Pythagoras. So this cosine of x and the sine of x given as such. So from this, we can be able to give, in terms of Pythagoras theorem, the square of the sine x sine x plus the cosine x cos x are going to represent the value of the radius squared. So we said that the radius squared is going to be in terms of 1. So therefore, this has an implication of the square of the sine of x plus the square of the cosine of x is going to represent unity. This is what we refer to as an identity, and of course we're going to encounter it in various forms and along our discussions on basic trigonometric functions and the various identities. So for now, I'd like to stop there, but I invite us to check our description box for various links of other similar videos, which are going to basically deal with the function graphs of trigonometric functions. So that is it for now, guys. Bye, God bless.